The University of Texas at El Paso College of Engineering, in collaboration with Halliburton, presents thermodynamic cycles. What is thermodynamics? Thermodynamics comes from the Greek root thermes, which means heat, dynamis, which means power. According to NASA, thermodynamics is the study of the effects of work, heat, and energy on a system. It is also concerned with the relations between them and the conversion of one into the other. Now we will review the 4 laws of thermodynamics. Zeroth Law of Thermodynamics establishes that if two systems are both in thermal equilibrium with a third, then they are in thermal equilibrium with each other. Imagine that we have 3 systems, A, B, and C. If system A is in thermal equilibrium with system B, which means that they have the same temperature, and system C is in thermal equilibrium with system B, then system A and C are in thermal equilibrium with each other. This law helps to define the notion of temperature. The first law of thermodynamics establishes that the change in internal energy of a system is equal to the heat added to the system minus the work done by the system. This is an application from the conservation of energy principle, which states that energy cannot be created or destroyed. It can only change from one form to another. We will go into more detail of this law later. The second law of thermodynamics establishes that energy can flow spontaneously from a system at a higher temperature to a system of lower temperature. Energy doesn't flow spontaneously from a lower to a higher temperature. For example, if we put a warm can of soda into ice, the heat will go from the can into the ice. The third law of thermodynamics establishes that the entropy of a perfect crystal at absolute 0 Kelvin is exactly equal to 0. Entropy is defined as the disorder of a system. For example, in the states of matter, liquid, solid, and gas, they are made of microscopic particles. In the solid state, the molecules are in order. This means that the entropy is lower. In the gas state, the molecules are in disorder. This means that the entropy will be higher. This law means that at absolute 0 Kelvin, there will be no movement of particles. After understanding these rules, let's examine the thermodynamic cycles. Let's define first thermodynamic cycles. A thermodynamic cycle is defined as a sequence of thermodynamic processes that involve heat transfer, work into and out of the system, while varying pressure, temperature, and other state variables within the system. Thermodynamic cycle can be divided into power cycles and refrigeration cycles. Power cycles produce power output and they are called engines. Refrigeration cycles, as its name implies, produces refrigeration. They are called refrigerators, air conditioners, or heat pumps. In order to analyze the thermodynamic cycles, 2 diagrams are used, which are the temperature entropy diagram and the pressure specific volume diagram. The specific volume is the reciprocal of density. The red graph is the phase change diagram of pure substances, for example, water. This diagram consists of a compressed liquid region, which is at the left of the graph, superheated vapor region, which is at the right of the graph, saturated liquid vapor region, which is under the curve of the phase diagram, and the critical point, which is where the saturated liquid and saturated vapor states are identical. Above this phase diagram, the thermodynamic cycles will be drawn. For example, These are the temperature entropy diagram and the pressure specific volume of the Carnot cycle. The area under the curve of these diagrams represents the net work produced, which is equivalent to the net heat transfer of the cycle. We will go into more detail of how to draw these diagrams later. Currently, there are various thermodynamic cycles which are involved in the generation of electricity. The most used cycle for generation of electricity in the US is the Rankine cycle. It is used in all baseload plants. These plants depend on steam-based power generation. These only fulfill their region's demand. They produce energy at a constant rate, and the most commonly energy source used is coal. When the energy generated by baseload plants is not producing enough electricity, it is when there is a higher demand for electricity during certain hours of the day or days of the week. In order to overcome this issue, some plants employ the Brayton thermodynamic cycle, which uses gas turbine for the generation of energy, therefore requiring natural gas for its operation. Now let's see how the Rankine cycle works.